Okay, let's graph an application. What we have is an electric current in microamperes in a certain circuit is given by this formula where it's a function of time, t is time in seconds, and it says sketch 3 cycles of this function. Well, I could have my graphing calculator do this, but I have to get an understanding of this equation first. So, like the amplitude is 3.8, etc. But you see this 3 pi in front of the parentheses? 2 pi in front of the parentheses. That 2 pi belongs to this term and that term. So before I go anywhere, I need to distribute that. So I'm going to have the cosine. Now I'm going to open the parentheses, and 2 pi times t is 2 pi t, and then 2 pi times 0.2 is 0.4 pi. So finally I have I equals 3.8 times the cosine of 2 pi t plus 0.4 pi. So this equation is now ready for me to work on it. Again, I don't know what to put for a window on my graphing calculator, so I'm going to come over here and start sketching this by hand. So the amplitude is 3.8. The period is 2 pi divided by what's in front of the variable x. Well, this is what's in front of the variable x, or t. Time is the independent variable on my x-axis here. So I've got to take 2 pi and divide it by 2 pi. Well, that's equal to 1 second for the period. That's how long it takes for one cycle of this curve. The displacement is the opposite of that 0.4 pi, so a negative 0.4 pi, divided by the value in front of the variable t, so the b value. The pi's cancel out, and when you take 0.4 and divide it by 2, you get 0.2. So this curve is displaced a negative 0.2 seconds. I'm ready to graph this. And I want to draw 3 cycles of this curve. And it's displaced off to the left of the y-axis a negative 0.2 seconds. It's a cosine curve whose amplitude is 3.8. It would normally start up here where x is 0 and y is 3.8. This one's going to start where x is a negative 0.2 and y is 3.8. Before I go any further, I'm going to take a quarter of the period. Well, the period is just 1. So a quarter of 1 is 1/4, or 0.25 seconds for this cycle. For a quarter of this cycle. Well, you see this 0.2 right there? So the first section of this curve is going to end at 0.05 right here, because I've got to move 0.25 seconds off to the right. So I'm going to put a little mark right here, and I'm going to try to force this cosine curve to be somewhat skinny and cross the x-axis right there. Here's another 0.25 and another 0.25 and another 0.25 to get through one period of this cosine curve. I'm going to put this negative 3.8 down here. The period is 1, and I went from a negative 0.2 all the way over to here 1 second. So if I go through that 0.2, how much do I have to go through here to get to a total of 1? Wouldn't that be 0.8 seconds? It says sketch 3 cycles of this curve. I've done 1. So here comes another portion of that. The period is 1. Right here I was at 0.8. If I add 1 to that, don't I get to 1.8 right here? And again, the third cycle of this curve, and I finish up right here. If this was 1.8, the full period is 1 second, so I'd be at 2.8 seconds here to finish off 3 cycles of this function. Please remember an arrowhead on the x-axis. Tell me that this is over time. This is the microamps for this circuit over time in seconds. You've got to come over here and label the y-axis as current in microamps. And then, I'm not too concerned about all these quarter points along the way. I am, though, concerned that you could put this into your graphing calculator. So I hope you would now look at this curve and go, oh, look, for 3 cycles of this curve, my minimum x value is a negative 0.2. I might go ahead and just put that in. And my maximum value for x, I might just go ahead and put in 2.8 to see if I did this properly, to see if I really get 3 cycles. I'm not going to worry about the scale. For y minimum and y maximum, I'm just going to put in a -4 because the minimum point is a -3.8. It's just easier to type in 4. And y maximum of a +4. And then I wouldn't mind if you would, once you see the graph of this curve, would you hit the trace key? And I'd like to remind you of how you can go to any point on that curve. So you could trace all over the place. But once you've hit the trace key, if you wanted to go to a particular spot, you could just then, right then and there, just hit a number. I want to go to 2.34 seconds. Well, here's 1.8. This one is about 2.05. So 2.34 is actually pretty close to, if not right at the bottom. It's right here somewhere, I think. And maybe in class you could tell me what that y value turned out to be, some -3 points, pretty far close to 3.8. Let's look at another couple problems before we end this segment. So now I say to you, I'm not going to give you the equation and ask you to graph the curves. I'm going to say write the equation for the given function cosine. This is kind of funny because of my math software I use, where I give you the amplitude, the period, and the displacement respectively. So I've given you the amplitude is 8. I've given you the period is 2 pi over 3. And respectively, I've given you the displacement is pi over 3. And I want you to write the equation y equals 8 times the cosine of something in front of the variable x and then some constant over here. So the 8 was the amplitude. I could fill it in right away. Remember, algebraically, we have previously discovered that while the period is 2 pi divided by b, we did the algebra and we moved the b value over here and the p value down there, and we said the b value is found by taking 2 pi divided by the period. And in this case, the period is 2 pi over 3. So 2 pi divided by 2 pi over 3 is, we're going to take the 2 pi in the numerator and multiply by the reciprocal of this, which is 3 over 2 pi. Those 2 pi's cancel out, and I'm left with a b value of 3. I'll go ahead and put that in right there. So a b value of 3. Let's do a little bit of algebra. Displacement is defined as the opposite of c divided by b. And in this problem, they gave us the displacement, and we just found out that the b value is 3. Let's go ahead. We got to find out what c is then, so that we don't have to do this every time. What do you say we do the algebra? I want to do this in blue. Let's do the algebra. Let's multiply both sides of the statement by the letter b so that those will disappear. And what we have now is b times d equals a -c, or a -1c. You can make this become c by, it's easier to say let's multiply both sides by a -1 versus divide both sides by a -1. It's just easier because this negative times this negative would give us a positive c, and c can always be found by taking the opposite of b times d. In this problem, I know that my b value is 3. My displacement is pi over 3. So when I multiply by pi over 3, the 3's cancel out, and I'm left with a minus pi. I'll put that in right here for my c value. Stop the video and do the next one if you would. Okay, respectively, the amplitude is 18, the period is 4, and the displacement is a -1, and I want to write a sine curve. So it's going to look something like this. Y equals 18 times the sine of. And I got to figure out what number goes in front of x, and then that constant right here. Remember, my b value is found by taking 2 pi divided by the period, which is 4, and 2 pi divided by 4 is 1/2 pi. I'm going to call that pi over 2. I'm going to put this in red. So my b value is pi over 2. Remember that my c value is found by taking the opposite of whatever b is times my d value. b is this pi over 2, so I take the opposite of that pi over 2, and I multiply it by my d value, which is a negative 1. So a negative pi over 2 times a negative 1 is a positive pi over 2. And now I can put in that c value. Again, don't forget, if you wanted to take this finished equation and do the calculations to find out what the period would be, so, like you can tell the amplitude should be 18, you could calculate the period is 2 pi divided by the b value, which is pi over 2. And so you'd take your 2 pi, multiply by 2 over pi, the pi's would cancel out, and you'd find the period is 4, just like was given. So you could check these without a problem. We're going to come back in one last segment, and we're going to play the game, What's My Function?